Now that you've had some practice with row operations, let's show you how we can have the calculator do the row operations for us. So we're going to solve this systems of equations, the 3y subtract 5z equal 1, etc. Written in matrix form. We'll have this as our augmented matrix, and we're going to put this into the calculator as matrix A. So on the calculator, matrix is one of my second options, so I first press second, then matrix, brings up the options, and what I want to do is edit a matrix, and I'll edit matrix A, so press enter here. Matrix A is a 3 by 4 matrix, so I'll enter 3 by 4, and then the calculator brings up an array that I can fill in with the constants. So I'll go across by row, 0, 3, -5, 1, 3, 4, -7, 5, 1, 2, -1, -3. And then to get out of here I can press second quit. Brings me back to the home screen. And then I like to always then pull up my matrix, and under names, matrix A is matrix 1, so I'll just press 1 and then enter, and it'll display my matrix, and I like to always double check it before I go any further. It's certainly easy to overlook a sign or just type in the wrong number. So two things we're going to look at in our calculators, something called REF, which is row echelon form of matrix A, and RREF, which is reduced row echelon form. So to get to row echelon form, again, I'm going to go into my matrix option, so second matrix, and I'm going to go over to math. Row echelon form, REF, is down here ways. There we go. It's option A here, so I can press enter. And then I need to tell the calculator what matrix I want it to do the row echelon form on. So I go back into my matrix menu and press 1 here under names to tell it matrix A. And then I press enter. And what I get is a little hard to read because I've got a repeating decimal. So I find it really helpful at this point to then go into my math menu and convert it to fraction form. And then it's a lot easier to see the matrix. And I'm still running a little bit off the edge of the screen, so I can cursor sideways, left or right, to see the whole matrix, which I've got pasted over here. And so what it's done is done all the row operations for us to put it in row echelon form. And I could then back substitute z equals -2, y subtract 5/3, z equals 1/3, substitute in z, do the back substitution, etc., like we've done before by hand. But I've got something even cooler to show you, and that's the reduced row echelon form. So second matrix, over to the math menu, and then we go down to reduced row echelon form, which could be option B here. Yes, right there. I can press enter, and again I need to tell the calculator what matrix to perform this operation on, and then enter. And what it's done is not only found the ones down the diagonals, the zeros below, but also zeros above, so I can read the solution to the matrix directly from this. X equals 1, y equals -3, z equals -2. And there's our solution to this system of equations without us having to think very hard at all. That's pretty nice, isn't it? Okay, let's look at the special cases. Okay, and these are examples out of the textbook. And we get my calculator back here again. So let's go ahead and run another one in here. Second matrix, edit, and I'll just go ahead and call this a new matrix A. So this one's still a 3 by 4 matrix, and then I'll put in my coefficients, 2, -3, 2, 13, 3, -4, -3, 1, 3, 1, -1, and 2. Second quit to get back to the home screen. And then again, I like to go second matrix 1, just to display the matrix I've typed in and double check that I've entered it correctly. And that looks all right. And then I can, being the lazy person that I am, second matrix, go to the math options. You can scroll up. It's a little bit quicker than scrolling down, but we're looking for the RREF. Tell it what matrix. And again, it solves it for us. X equals 2, Y equals -1, Z equals 3. And we got our solution as an ordered triple. Okay, the next one's going to be one of our special cases. So I'm going to edit. And what I'm now looking at is this system over here. And again, this is one out of the textbook. It was number 34. Always feel free to pause the video so you can type things into your calculator just to follow along and do it as I'm doing it. You get comfortable with it. If anything weird happens, remember you can always press second quit to get back to the home screen and start over again. And double checking my matrix. 2, 1, 5, 5, 2, 12, 2, -3, 1, -1, 5, 10. I like to always enter my matrices as rows and then check it by columns. And doing our reduced row echelon form. Matrix A. And I wanted to show you this one because it's one of our special cases. So when we look at it, we don't quite have our ones on the diagonals. That's usually the first hint that there might be something odd on this one. In particular, look at the bottom row. It's saying 0x plus 0y plus 0z equals 1. It's saying 0 equals 1, which is not true. So this would be our no solution case. Okay, and then if I've got a couple minutes, let me pop back here and look at a couple of story problems. They're just common story problems you may have run across in the book. So this one's from 6.1, number 49. We have a plane flying both with the wind and against the wind. When the plane is flying against the wind, the speed of the actual plane is going to be the basic speed of the plane, subtract the wind. And when the wind's pushing it, then the speed of the plane plus the speed of the wind is the total speed of the plane. And we know that it can fly with the wind 450 miles in 3 hours. Flying against the wind, it covers the same 450 miles in 5 hours. Distance equals rate times time. So the 450 miles equals the speed of the plane with the wind times the 3 hours it takes. And then 450 miles equals the speed of the plane against the wind times the 5 hours it then takes. And that'd be how we set up the problem. And then here's another one out of the textbook. We have a bucket of coins containing nickels, quarters, and dimes. We know there's a total of 740 coins, and they have a dollar value of $157. We're also given a third piece of information. There's twice as many nickels as quarters. Because we're looking for 3 different things, nickels, the number of nickels, the number of quarters, the number of dimes, we're going to need 3 different equations. So our first equation is the easy one. If N, Q, and D are just the little number of shiny pieces of metal, the number of nickels, the number of quarters, the number of dollars. I'm sorry, the dollars, not dimes. The number of nickels plus the number of quarters plus the number of dollars equals a total of 740 coins. And then our next equation has to do with the monetary value of those little pieces of metal. We know 0.05 times the number of nickels is the total value of nickels in the buckets. 0.25 times the number of quarters in the bucket is the total value of all the quarters in the bucket. And then 1D is the value of the dollars. And we know the dollar value total is 157. And then here's the tricky part. There's twice as many nickels as quarters. And so I find it helpful with these to sometimes make up some numbers just to make sure I feel comfortable with it. So since there's twice as many nickels, if there's 10 nickels, that means there's only 5 quarters. If there's 20 nickels, there's 10 quarters. If there's 2 nickels, there's 1 quarter. So I know my nickels equals twice the number of quarters. And that gives me my third equation. Putting it in standard form, I'm going to subtract the 2q, get it equal to 0. And then I can set up I've got my equation set up, put them into matrices, can put it into my calculator, and solve from there.